This is Evren. Let's get into it. Imagine an object so dense that a single teaspoon of its material would weigh more than a mountain. An object wrapped in a magnetic field so intense that it bends atoms out of shape, erases digital memory from thousands of miles away, and rewrites the laws of chemistry. This is a magnetar. They are the most magnetic objects in the known universe, the collapsed, super-dense cores of massive dead stars. When a giant star explodes in a supernova, its core collapses down into a sphere roughly 20 kilometers across, about the size of a city. While a standard neutron star already possesses a magnetic field billions of times stronger than Earth's, a magnetar is a rare, hyper-extreme variant. Its magnetic field is 1,000,000,000,000 times more powerful than our planet's. So what would actually happen if one of these objects appeared in our cosmic neighborhood at the exact distance of the moon? You would not see a fiery wall approaching. You would not feel heat or see a blinding flash of light. The destruction would arrive silently, moving at the speed of light. At a distance of nearly 400,000 kilometers, the magnetar's magnetic field would instantly sweep across Earth. Within milliseconds, every electronic device on the planet would cease to function. All power grids across the globe would burn out simultaneously. Digital data stored on every server and hard drive on Earth would be wiped clean. Electric currents forced through the upper atmosphere would ignite global auroras brighter than the full moon. As the magnetar draws closer, the magnetic field begins to interact directly with chemistry itself. At distances under 100,000 kilometers, the magnetic forces become stronger than the electromagnetic bonds holding atoms together. The field physically distorts the electron clouds surrounding atomic nuclei, squeezing spherical atoms into long, thin, needle-like shapes. Because all molecular chemistry depends entirely on the shape of electron orbitals, chemistry simply stops working. Biological molecules, cell membranes, and DNA strands lose their structural integrity. Your biology unravels at the atomic level long before your brain can register a single nerve impulse. Simultaneously, the immense gravity of the magnetar, packing more mass than our sun into a city-sized sphere, exerts catastrophic tidal forces. The gravitational pull on the side of Earth facing the magnetar would be vastly stronger than on the far side. The crust would fracture, oceans would vaporize, and the planet itself would be stretched and pulverized into a stream of molten debris, forming a glowing ring around a dead star. This sounds like pure theoretical fiction, but magnetars are very real. In December 2004, a magnetar named SGR 1806-2O released a giant flare of radiation. That star sits 50,000 light-years away, on the far side of the Milky Way galaxy. Yet when that burst of energy reached Earth after traveling for 50,000 years, it was powerful enough to physically ionize Earth's upper atmosphere, disrupt communications, and saturate satellite detectors across space. From 50,000 light-years away, an object no larger than a city impacted our planet. A magnetar does not need to be close to be dangerous. The reason human civilization exists is not because the cosmos is gentle, but because the universe is vast. We live in a quiet, fragile pocket of space, shielded only by the immense distances separating us from forces that could unravel Earth in a fraction of a second. If this changed the way you see our place in the cosmos, that is what Evren is for. Subscribe and we will see you in the next one.